Going to roll through review 3 here with you. The construction should have been done in class. We're not going to do the constructions on video. Please make sure you do see me for help on those before the quiz. All right, so starting off with number 1, if a rectangle is not a square, what is the greatest number of lines of symmetry that can be drawn? So we're going to draw a rectangle that's not a square, sort of, kind of, right? So there's just a regular rectangle, regular looking rectangle. It can't be a square though. What's the greatest number of lines of symmetry that can be drawn? Well, obviously you have 1 right there. We have 1 right there, and you cannot draw the diagonal symmetry, because when you fold along that line, it will not land on itself. Okay, it will not. So it's only 2. If you had a square, then you could do the diagonals and you'd have 4. So again, a square would be 4. Which kind of symmetry does the word toot have? Okay, so, well, it looks like the word toot, we can only do a line of symmetry right down the middle, vertically. See, if you draw and you fold the paper right in between the O's, right? If you fold right in between the O's, it'll land on itself. That's vertical symmetry only. Cannot be done horizontally. Which letter has horizontal but not vertical symmetry? Horizontal but not vertical. So horizontal is this way, vertical is up and down, right? So horizontal only would be the B, right? B has horizontal and it does not have vertical, so that would be A. Which letter has point symmetry? Point symmetry review, we haven't talked about point symmetry, but point symmetry is when you can do a 180-degree rotation. So basically turn your paper upside down. Turn your paper upside down, you can do it right now. Which letter looks exactly the same? And of course it's the N, and that's the one that has point symmetry. Which letter has both point and line symmetry? Okay, so again, turn your paper upside down. Which letter looks the same? H does and S does. So it can't be A and it can't be M, because those don't have point symmetry. Which one has also line symmetry? S does not have line symmetry. H has line symmetry, obviously. So it would be H would have point and line symmetry. Which figure has 120-degree rotational symmetry? Well, 360 divided by 120, because that'll tell you the order. So we're looking for an order of 3. All right, divide by 360, or divide 360 by the angle they give you. Divide the angle they give you. Divide 360 by the angle they give you. Yes, and so you're looking for the one that has 3 sides and that, or 3 points, 3 vertices, and of course that is the equilateral triangle. So an equilateral triangle, if you draw that out, okay, you can rotate it 3 times and have it look exactly the same. So if it has an order of 3, each angle is 100. It's 120. All right. So that would be the equilateral triangle. All right, rolling through here. Which symbol has 90-degree rotational symmetry? Okay, so 90, 360 divided by 90 is 4. So you're looking for the one that can be turned 4 ways. Okay, four different ways and look the same. Now, it's arguable. It's arguable that, well, not really for an X, because, you know, if you draw it like that, you know, maybe if you turn it, it isn't quite exactly the same. But we're going to argue that the way they drew this X here, no, actually, even the way they drew that doesn't even look like it. But if you draw an X, okay, it depends how you make your X, right? But it's arguable that you could turn it 4 ways, right? 4 ways and have it look the same. Now, certainly H, you cannot turn 4 ways and look the same. N and S. So you knew it couldn't be those. X would be the only logical answer, but I know it could be argued that none of these really would have 90-degree rotational symmetry, right? All right, so we're gonna say that it's the X, but we're gonna put a little asterisk there, like, I don't like that question too much. All right. Which transformation does not preserve orientation? Does not preserve orientation. All right, so remember that's the order. When the order changes, and of course the only way the order changes is when you flip. All right, so reflection does not preserve the orientation. That's just right from your notes. Which rotation about the origin is equivalent to rotation 125? Remember, all rotations are equivalent when you add or subtract 360. So it's either add 360 or subtract 360. So add 360 to 125 and you're going to be way high, right? None of the choices are that. So let's try taking away 360. 125 take away 360 is negative 235. So that's the one that's going to have the same, it's going to be equivalent, okay? Just add or subtract 360 and it's the exact same rotation. It's just a going around one more time. Going around a circle one more time. The composition of line reflections represents what type of isometry? Okay, this is a double reflection over intersecting lines. So I'm going to kind of explain this one a little bit. The y equals x line we should know. The y equals x line is this line right here. Kind of. Okay, that's the y equals x line. And the x equals 5 line is x equals lines go up and down. So here's the x equals 5 line. The point is, the two lines they're reflecting over are intersecting. So double reflection over intersecting lines, double reflections over intersecting lines create a rotation. So it's reflect, right? We're going to reflect, and then we're going to reflect again, reflect and reflect, and as it's doing the two reflections, it actually rotates. We spent a whole lesson on double reflections, a double reflection over intersecting lines. We just didn't see it with the notation necessarily, right? So it would be a rotation. Double reflection over intersecting line is a rotation. What's the value of x that makes the lines parallel? We've done a bunch of these. This is a review. This is old, right? These are corresponding angles. Those are equal. So 3x plus 17 equals 4x minus 12. All right, and then subtract 3x and add 12. 29 equals x. All right, just subtract 3x and add 12. So x equals 29, that's D. What is the image of 5, negative 2 under the transformation reflection y equals x? We did our rules. Go back and look at our coordinate rules. Reflection over y equals x, the rule is you just switch the x and the y. So 5, negative 2 becomes negative 2, 5. So that would be D. All right, on to page 2. I think we're rolling through pretty good here. This one here is a rotation, okay, that ABC is just rotated around 180 degrees, and it's rotated around some point, maybe that point right there, right? Rotate around that point, and you get A prime, B prime, C prime. So that's a rotation. 14, find the image of point 6, negative 2 under rotation 90. Again, coordinate rules. Rotation 90, the rule for rotation 90 is negative y x. All right, so we're going to switch the numbers, 2, 6, and then change the sign of this one. So that's going to become just 2, 6. All right, and this is a fourth quadrant, and it's going into the first quadrant. Rotate 90 from the fourth quadrant, you go into the first quadrant. That's another way to look at it. You want to draw yourself a little graph. 6, negative 2 is right here, and then if you rotate, it's going to go right there. Rotate 90 degrees, one quadrant, right? And everything's positive. So that's another way to look at it. Don't forget, every rotation 90, you switch the numbers. Rotate 180. Negative 180 is the same as 180. They flip and they flip. All right, so I'm going to do another little graph here. Negative 4, negative 7 is like right here. All right, so a 180 is going to go two quadrants. So fourth, it's actually going to go up here. Okay, and the numbers flip and flip again. Flip, flip. So it's going to be positive 4, 7. They flip and flip back. So they go to 4, 7. We're in quadrant 1. It's positive, positive. Reflection over the x-axis, just change the sign of the y. Change the sign of the y. So it's negative 2, negative 4. You can also draw yourself a little graph. Reflection, for this one I'm going to draw a little graph. Reflection over the y, x equals 2 line. So here's the x and y axis, okay? I'm going to draw in different color. The x equals 2 line is this line right here. Okay, that's that vertical line at 2. Now, if I'm at 4, negative 3, all right, so here's 1, 2, 3, 4. If I'm at 4, negative 3, that's down here. I'm going to reflect over this line. All right, so how many units away from the line am I? I'm 2 units away. I'm 2 units to the right, so I'm going to go 2 units the other way. I'm going to be right here. See that reflection? Remember we did the actual reflections? All right, so there it is, and that is the point 0, -3. That's going to be 0, -3. All right, and reflection over, we'll do one more of those. All right, so let's do the same thing. We're going to draw a little graph there. Okay, now it's the y equals 5 line. The y equals 5 line is, and let me do this a little bit better here. Let me do it like this, because I want to do more above, right? The y equals 5 line is like right here. Okay, there's the y equals 5 line. Let's say this is 5, so it's 1, 2, 3, 4, 5, 6, 7, 8. There we go. All right, so 2, 7. 2, 7 is right here. And then, because that's 5, right? So, and then go the other way. Right over that line. Just flip right over that line. And you are at 2, 3. So it's going to be 2, 3. All right, number 19. Number 19. A reflection over which line does not carry the square onto itself. Okay, so if we reflect over y equals x, there's the y equals x line. Fold your paper on that line. Does the square go onto itself? Yes, it does. We're trying to find the one that does not carry onto itself. So that's not the answer. Y equals 2. Okay, y equals 2 is right here. Kind of. Okay. Fold along that line. Does the square go onto itself? Yes, it does. Just fold your paper. You'll see it. X equals 5. 1, 2, 3, 4, 5. Here's the x equals 5 line. If you fold along that line, will the square land on itself? No, it's going to land on the other side of the line. So there's my answer. Okay, and then x plus y equals 4. That's the same thing as y equals, you just move the x over, -x plus 4. You'd have to graph that line, but that ends up being this line right here, just to save time. They're talking about this line right here. How do I know? Well, I know the y-intercept and the slope. I can graph that line. I know how to graph lines. I should know how to graph lines. But you don't even have to. You already know it's C, so we're going to move on. All right, number 20 is construction. 21 is a construction. 22, all right, 22. Interesting question here. They give us information. They give us that this is 50 and that this is 115, and they're going to make us explain why these are parallel. Well, they're parallel if I can show alternate interior angles, something, or corresponding angles, something congruent. So watch this. If this 115, obviously we know this is 65. I'm going to change colors. We know this is 65. We should know that by now. Okay. This is a key part of the problem. If you didn't see that, GH is congruent to IH. So I have an isosceles triangle. If I have two sides of the triangle congruent, I have two angles congruent. So guess what? These two angles are both 65. Okay? If those are both 65, okay, 65 and 65 is 130. So what's left over for my triangle? 180 minus 130 gives me 50. All right, so this must be 50. Now, I'm going to erase everything. I'm going to erase everything except this. Look at. I have a 50 here because of what we just talked about, and I have a 50 here, and those are corresponding angles. I have two parallel lines. I must have two parallel lines cut by a transversal. Okay, so how am I going to explain that? So I'm going to talk about angle GIH is 65 degrees because it's a linear pair. It's a linear pair with angle DIG, which was given. That gives me that. Okay, we're going to say angle IGH. Angle IGH is 65 degrees because we have an isosceles triangle. And then I'm going to say angle GHI is 50 because three angles of the triangle add up to 180. And then obviously I have parallel lines. AB is parallel to CD because corresponding angles. Are congruent. If you know the corresponding angles are congruent, the lines must be parallel. Okay. Now we're actually going to be getting into proofs. Proofs involved in this, but this is just using angle measures and kind of showing it that way. All right. So we have another construction, right? We have another construction on 23. 24, pretty simple. For 24, this is the image. Okay. D prime, E prime, F prime is going to be the image of DEF after translating a long line L such that point D is mapped onto point A. So watch what happens. If point D goes to point A, right? If point D slides over to point A, what's point F going to do? Well, point F is going to slide over to point C if you do a translation. So it's going to be point C. And my explanation is in a translation, all points move the same distance. In a translation, all points will move the same distance. So if D goes to A, F has to go to C. If it's a translation, they said it was. All right, and then 25 is a construction. 26, all right, I'm gonna bang these out for you. We're doing a reflection over the y-axis. Now I'm not going to graph these. You guys know how to graph points. I'm going to use the coordinate rules. Reflection over the x-axis, all right, is going to be change the sign of the x. So A prime is going to be change the sign of the x, -3, 4. Okay. B prime is going to be -1, 7. And C prime is going to be -3, 7. Again, you're just changing the sign of x because I'm reflecting over the y-axis. If you can't see it, put it on the graph and you'll see it better. For the y equals x reflection, we take what we have for A prime, B prime, C prime, and we switch them. Because reflection over the y equals x, you just switch the x and the y. So I'm taking these guys and I'm switching them. A prime prime is going to be 4, -3. B prime prime is going to be 7, -1. And C prime prime is going to be 7, -3. And then my last one's a translation, but it's a translation of A prime prime. That's what A triple prime is going to be. So A triple prime, B triple prime, and C triple prime. What do? I take my x, I add 5. I take my y, I subtract 1. So here's my x is 4, I'm going to add 5, that's 9. My x is -3, I'm going to subtract 1, I get -4. My x is 7, I'm adding 5, I get 12. My y is -1, I subtract 1, I get -2. 7 plus 5, 12, and then -4. Right? -3 minus 1, -4. All right, so there's all my coordinates. Graph them, make sure you have those graphed, and I will see you for the quiz.